Welcome, aviation enthusiasts and curious minds, to a fascinating journey into the world of aeronautics. In today's video, we're set to explore some of the most extraordinary and peculiar aircraft ever created, machines that defy conventional design and push the boundaries of what we thought possible in the realm of flight. From massive cargo giants to experimental prototypes, these are the world's most strange planes. So buckle up and get ready for a thrilling exploration of innovation. Number 6. Conve XFY Pogo. The Conve XFY Pogo was an experimental vertical takeoff and landing VTOL craft developed by Conve Consolidated VLT Aircraft Corporation in the 1950s. Its primary purpose was to explore the feasibility of creating an aircraft capable of vertical takeoff and landing, like a helicopter, but with the speed and performance characteristics of a conventional jet fighter. The XFY Pogo had a distinctive and unorthodox tail-sitter configuration. The aircraft featured a slender fuselage with swept wings and a vertical tail, and it was equipped with a large propeller at the nose. Its unique design allowed it to take off and land vertically by pointing its nose upwards, with the tail resting on the ground. Once airborne, it would transition to a horizontal flight, with a pilot flying it like a conventional airplane, powered by a single Allison UD-40, a 16 turboprop engine. The XFY Pogo was a challenging aircraft to fly. Pilots had to rely on a complex system of mirrors and periscopes to provide them with the necessary visibility during vertical takeoffs and landings. The transition from vertical to horizontal flight was also a delicate process that required precise control. The XFY Pogo completed its first vertical takeoff in 1954. However, the development process was plagued with difficulties, including stability and control issues. Despite the initial success of vertical takeoffs, the transition to horizontal flight proved problematic. The program was ultimately cancelled in 1956 after a series of accidents and challenges in overcoming the aircraft's inherent design limitations. Although the Conve XFY Pogo did not lead to the development of operational VTOL aircraft, it remains a notable part of aviation history as an experimental platform that pushed the boundaries of conventional aircraft design in the pursuit of vertical takeoff and landing capabilities. Number 5. Lockheed Martin P791 Hybrid Airship. The Lockheed Martin P791 is a hybrid airship, a unique aircraft that combines elements of traditional airplanes, helicopters, and airships. Designed by Lockheed Martin's Skunk Works division, the P791 was intended for various military and civilian applications. The key feature of the hybrid airship is its ability to take off and land vertically VTOL, like a helicopter, while also having the capability for sustained horizontal flight. The P791 has a distinctive shape, featuring a tri-lobe hull with 3 lobes or inflated sections. The airship's envelope is filled with helium, providing lift, while the controllable propellers on the outer edges of the lobes allow for vertical and horizontal propulsion. The hybrid design aims to combine the benefits of airships, such as long endurance and low fuel consumption, with the versatility of VTOL aircraft. One of the advantages of hybrid airships like the P791 is their ability to access remote or inaccessible areas without the need for traditional runways. This makes them suitable for various applications, including cargo transport, surveillance, and reconnaissance. The P791 was designed to carry heavy payloads and operate at altitudes and speeds that traditional airships couldn't achieve. The development of the P791 was part of Lockheed Martin's efforts to explore innovative solutions for transportation and logistics. While the P791 itself did not enter mass production or widespread use, the technology and knowledge gained from its development contributed to ongoing research in the field of hybrid airships. Lockheed Martin's work on hybrid airship concepts has influenced discussions on potential roles for such vehicles in the future. especially in applications that require access to remote or austere environments. Number 4. Boeing X-37B. The Boeing X-37B is an unmanned spaceplane that has garnered attention for its secretive nature and its association with the United States Air Force USAF and the Department of Defense. The X-37B Orbital Test Vehicle (OTV) is part of a program aimed at testing and demonstrating reusable space technologies for future space missions. Developed by Boeing's Phantom Works, the X-37B project has been shrouded in secrecy, and many details about its specific missions and capabilities are classified. The X-37B has a distinct resemblance to a miniature space shuttle, featuring a delta wing design and a payload bay for carrying experiments and technologies into space. It is approximately 29 feet (8.8 meters) in length and has a wingspan of about 14 feet (4.3 meters). The spaceplane is capable of autonomous orbital flight, including orbital maneuvers and re-entry into Earth's atmosphere. One of the key characteristics of the X-37B is its reusability. After completing a mission, the spaceplane can autonomously return to Earth, land on a runway, and be prepared for subsequent flights. This reusability aspect aligns with a broader trend in space exploration to reduce costs and enhance the efficiency of space missions. The specific details of the X-37B's missions, payloads, and objectives have been closely guarded by the U.S. military. The spacecraft has conducted multiple classified missions, with each mission's duration ranging from several months to over a year. It has been used to test technologies in a space environment and to conduct experiments related to various scientific and military applications. While the X-37B is often referred to as a spaceplane, it operates in low Earth orbit and does not travel to the Moon or beyond. Its missions remain classified, leading to speculation and intrigue about its true purposes. The X-37B program reflects the ongoing interest in developing and testing innovative space technologies, with potential applications for national security and space exploration. Number 3. Solar Impulse 2. Solar Impulse 2 C2 is a groundbreaking solar-powered aircraft that gained international acclaim for completing a historic around-the-world flight using only solar energy. The project was initiated by Swiss aviators Bertrand Piccard and Andr Borschberg, who aimed to demonstrate the feasibility of using renewable energy for long-duration flights and to promote clean technologies. Solar Impulse 2 has a wingspan of approximately 236 feet (72 meters), which is wider than a Boeing 747, and it is equipped with 4 electric motors. The wings are covered with 17,248 solar cells, providing the necessary energy to power the aircraft during the day and charge its batteries for nighttime flying. The solar cells capture sunlight to generate electricity, which is stored in lithium polymer batteries. The aircraft's journey around the world began on March 9, 2015, in Abu Dhabi, United Arab Emirates. The route included stops in various countries, allowing the team to showcase the aircraft's capabilities and engage with the public and policymakers on the importance of renewable energy. The journey covered a distance of approximately 26,098 miles, 42,129 kilometers, and was completed in multiple legs. One of the key challenges of the Solar Impulse 2 project was its reliance on solar power, making the aircraft highly dependent on favorable weather conditions. The team had to carefully plan each leg of the journey to maximize exposure to sunlight and avoid adverse weather. The flight duration for each leg varied, with the longest non-stop flight lasting over 4 days and nights. The historic journey marked several milestones, including the first solar-powered flight across the Pacific Ocean. The aircraft demonstrated the potential of solar energy in aviation, showcasing the importance of sustainability and the need for clean technologies in the aerospace industry. The Solar Impulse 2 project aimed not only to achieve a remarkable feat in aviation, but also to inspire and advocate for the use of renewable energy in various sectors. The success of the around-the-world flight underscored the progress made in solar aviation and contributed to discussions about the future of sustainable air travel, while Solar Impulse completed its around-the-world journey in 2016. The project's impact continues to influence discussions on the integration of renewable energy in aviation and the development of innovative, eco-friendly technologies. Number 2. StratLaunch. StratLaunch is a massive aircraft designed for air launch to orbit, and it gained attention for having the widest wingspan of any aircraft ever built. The project was founded by Microsoft co-founder Paul G. Allen, and its development began with the goal of providing a flexible and cost-effective platform for launching rockets into space. The aircraft was intended to serve as a mobile launch platform capable of carrying a variety of launch vehicles to high altitudes, where they would be released for satellite deployment or other space-related missions. The most distinctive feature of StratLaunch is its enormous wingspan, which measures approximately 385 feet 117 meters. The aircraft has a dual fuselage design, with two fuselages mounted on the wings, and it is powered by 6 turbofan engines. This unique configuration allows the aircraft to carry and release launch vehicles from a central position between the fuselages. StratLaunch was developed by Scaled Composites, a company known for its work on innovative aerospace projects. The aircraft was designed to be capable of carrying multiple launch vehicles, providing a flexible and adaptable solution for a range of payload sizes and mission requirements. This air launch approach was envisioned to reduce the cost of launching payloads into space and increase the operational flexibility of satellite deployment. The development and testing of StratLaunch involved a series of ground and flight tests, including taxi tests where the aircraft moved along the runway under its own power. The full operational capability and commercial use of the StratLaunch system were yet to be realized. While Paul Allen, the original visionary behind StratLaunch, passed away in 2018, the project continued under new ownership. The company continued to explore potential applications for the aircraft, including launching satellites and other payloads into low Earth orbit. However, the commercial viability and success of the StratLaunch system remained a subject of ongoing development and evaluation. Number 1. Antonov An-225 MRIA. The Antonov An-225 MRIA is a colossal cargo aircraft, renowned as the largest and heaviest airplane ever built. Designed in the Soviet Union during the 1980s, the An-225 was originally intended to transport the Buran space shuttle and other oversized payloads as part of the Soviet space program. The aircraft's name, MRIA, translates to dream in Ukrainian, reflecting the ambitious nature of the project. The An-225 is characterized by its 6 turbofan engines, massive wingspan, and a distinctive twin-tail design. Its wingspan measures an astonishing 88.4 meters, about 290 feet, making it significantly wider than any other aircraft in operation. The aircraft has a maximum takeoff weight of around 640 metric tons, and it features a cargo compartment that is 43 meters long, 6.4 meters wide, and 4.4 meters high. One of the most notable missions of the An-225 was transporting the Buran space shuttle. The aircraft carried the Buran on its back, secured to a specially designed mounting structure. The combination of the An-225 and the Buran on top made for a striking and iconic image. Following the collapse of the Soviet Union and the discontinuation of the Buran program, the An-225 was stored for a period, but later brought back into service for various cargo transport missions. The An-225's massive payload capacity makes it suitable for transporting oversized and heavy cargo, including industrial equipment, machinery, and other exceptionally large items. Its versatility and unique capabilities have made it an invaluable asset for transporting goods that cannot be accommodated by other aircraft. The N225 remained the only operational aircraft of its kind. Its size and capabilities have made it a showstopper at airshows and aviation events worldwide. The aircraft has undergone modifications and upgrades over the years to enhance its performance and extend its operational life. While the N225 has faced challenges, including periods of inactivity and financial difficulties, its iconic status and capabilities have solidified its place in aviation history. The N225 serves as a testament to the engineering prowess of Antonov design. Bureau N continues to capture the imagination of aviation enthusiasts globally.